Video about classifying critical points. This one's going to have multiple critical points, more than 2 in fact. So let's get down to it. So here's our function. It's f of xy equal to 6xy minus x squared y minus xy squared. Here's my first partial. Fx is 6y minus 2xy minus y squared. These words are kind of loud. And our partial to y is 6y minus x squared times 1 minus x times 2y, which is 2xy. Also, my second partial is over here. Fxx is negative 2y, right? The derivative with respect to x is just negative 2 times y. Fyy is just going to be negative 2x, right? Derivative of y here is 0, and derivative with respect to y here is negative 2x times 1. And fxy is actually complicated. The derivative with respect to y is 6 minus 2x minus 2y. Same deal here. If this is fyx, you would get 6 minus 2x minus 2y. Okay, so let's find the critical points. So we're going to set these each equal to 0, and it's actually going to get kind of messy. So let's look at this. Let's deal with the second one here. So I've got 6x minus x squared minus 2xy equal to 0. And here it makes sense to factor out. So I've got x times 6 minus 2x minus 2y. Sorry, not 2x. That's just minus x. I'm factoring out x equal to 0. So I've either got x equal to 0 or 6 minus x minus 2y equal to 0. Which is easiest if we say, well, that's going to turn into 6 minus 2y equal to x. Okay. Now again, these aren't critical points yet. These are just solutions to this first point here. This second partial equal to 0. If we do the same thing here, I can factor out a y and say I've got y times 6 minus 2x minus y equal to 0. There definitely is some symmetry here between x and y. Don't sweat it. So here I get y equal to 0 or 6 minus 2x minus y equal to 0. Solving for y, you get 6 minus 2x equal to y. So again, both of these equations have to be 0 at the same time. So one option would for x and y both to be 0, right? If x is 0 here and y is 0 here, or if x is 0 everywhere, you get 0 times whatever. If y is 0 everywhere, you get 0 times whatever. So 0, 0 is definitely a critical point. But you could also have x equal to 0, which would make this one 0. And if x is 0, you could have y 0, but we're going to do that. You could also have if x is 0, then y is 6 minus 0, which is 6. And that works, because if x is 0 and y is 6, I get 0 times some stuff here, and then I get 6 times 6 minus 0 minus 6, which is 0. So this part's 0 here. In a similar way, if y is 0, well, that whole thing's 0, and if y is 0, then we can say x is going to equal 6 minus 0, which is 6. Right, and that's going to, again, if y is 0, this whole thing will be 0. If x is 6, you'll get 6 times this part, which is going to be 0, because you get 6 minus 6 minus 0. Finally, you have the situation where you have to have both of these parts be true. And so that's where we're going to set one equal to the other one, or plug in x for the other one. So I'm going to say, like, I'm going to plug in x equals 6 minus 2y for x. So you get 6 minus 2 times 6 minus 2y, the y. And you get 6 minus 2 times 6 is minus 12, plus 4y equal to y. 6 minus 12 is negative 6. Subtract 4y, you get negative 3y. Sorry, that's equal to negative 3y. So you get y equal to positive 2. If y is 2, then, where did my equation go? X equals 6 minus 2 times 2, which is 6 minus 4, which is 2. So x also equals 2. So my fourth and last critical point is 2, 2. And we can see if x is 2 and y is 2, you get 2 times 6 minus 2 minus 4, which is 0. Here you get 6 minus 4 minus 2, which is 0. So these are my 4 critical points. Now we're going to classify them all. So again, my second partials, fxx was negative 2y, fyy was negative 2x, fxy was 6 minus 2x minus 2y quantity squared. And there are my 4 critical points, which we're going to classify. So at 0, 0, we get 0 times 0 minus 6 minus 0 squared. That's negative 36, which is negative. So we have a saddle at 0, 0. At 0, 6, we get still 0. Right? We're going to get 0 here every time. So once I get 0 here, I know I'm going to get something that's probably going to be a saddle, because 0 minus something that's probably not 0 squared is going to be negative. Let's plug it in. 0 for x, 6 for y. 6 minus 0 minus 2 times 6 squared. You get 6 minus 12 is negative 6. 0 minus negative 6 squared is negative 36. Again, that's less than 0, so we have a saddle. At 0, 6. I think we're going to get the same thing at 6, 0. Right? D of 6, 0 is going to be plugging 6 and 0. Yep, we're going to get 0 there. Plugging 6 for x, we're going to get 6 minus 12, which is negative 6 minus 0. So yeah, we get minus negative 6 squared. So we also have a saddle at 6, 0. And then finally, at the point 2, comma 2, we're going to get, let's see, negative 4 times negative 4 is positive 16. Minus 6 minus 4 minus 4, which is going to be something. I can do math, right? 16 minus, see, 6 minus 4 is negative 2 squared, which is 16 minus 4, which is 12, which is positive. So then I have to check the second partials, and if I plug in, say, my critical point 2, 2 to either of the second partials, fxx at 2, 2 is going to be, well, fxx is negative 2y, so we get negative 2 times the y value, which is negative 4, which is obviously negative. So that means it's concave down, which means we have a maximum. So we have a maximum at 2, 2. All right, I hope that helps clarify these critical points of